And really what I'm going to do is what is AI in about 15 minutes, with the caveat that there is no way to do AI in 15 minutes, but I hope that I can give everybody a feel for the basics, for qualitatively what it is and why it's so important. I will warn you, I do have 3 or 4 more hardcore slides in here. We're not going to go into depth in them, but I wanted to include some stuff for the AI experts that are really on the call mainly to hear how somebody else explains it to people. I'm sure most people are here though to learn about it, and I hope that over the course of my intro and then Charlie's case studies and Kimberly's guidance on how to learn more and accelerate into it, we give you enough to really start that journey. So jumping into it, you've all heard the hype. I included a handful of quotes on this slide, and the important thing is not to read every word of all of these, but to note that all of them are making incredibly grand statements. I like Andrew Ng's here, the second one down. Just as electricity 100 years ago transformed industry after industry after industry, I think AI powered by deep learning, which I'll talk about, will now do the same. It's really hard to think of an industry that won't be transformed by AI over the next decade. AI is the most hyped technology on the Gartner hype curve most of the last several quarters, and with good reason. It's got some amazing capabilities. It's not magic, it can't do everything, but it is a powerful set of technologies that we'll start talking about. First, I want to talk about the motivation. Every year in January, I do speak for the Austin Forum in an annual event. It's all about tech trends and predictions. But let's be honest, predictions are hard, and I hope nobody goes back and checks us on those year after year after year. But there are 2 certainties driving AI. This one has nothing to do with AI. People always want insight and foresight. You want to know, is the clan in the valley across the river going to attack? Is the saber-toothed tiger going to attack? Do I need to rotate my crops to feed my tribe, et cetera? So for all of humanity, we've wanted to understand what's going on, to be able to protect those around us. And as we develop language and the ability to be cognitive and think about scenarios, what might happen next? And so we've developed some data analytics techniques to support our human intelligence in this. You've all seen databases before, and you've read reports of past activity before, and that's hindsight. And you use that to inform your human intelligence to try to figure out, well, based on what did happen, what do I as a human think might happen next, and how can I optimize for it? And we've developed progressively more capable analytics to do that because data continues to increasing scale at a very steep exponential. Now this we also feel certain about. Barring the zombie apocalypse, we believe that there is no near-term limit on this exponential increase in data. If you think about it, we really haven't begun to instrument the world around us. We're riding on the curve of Moore's law, making more powerful devices and more of those devices. And those 2 exponentials create this steep exponential and data growth scale. And big data is here to stay for all of those reasons. The computers are getting more powerful, mobile devices are getting more powerful, there's more and more sensors and instruments, and yet, as I said, we still have barely scratched the surface of instrumenting the world around us. So big data is here to stay, and considering we always want to know what's going to happen and why and how we can influence it, we're going to keep advancing our data analytics techniques. This slide looks a lot like the slide 2 slides ago that I just showed you, in the sense that it shows there is descriptive analytics that tells you what happened. And you can think of that as looking at files or relational database management system reports and so on. There's diagnostic analytics, and you can think of Excel and Tableau and Power BI and tools like that as telling you what's actually going on right now. And then there's predictive analytics. What do we think is going to happen next? Now, humans have always tried to figure out what's going to happen next, and we've used our own human intelligence and our historical experiences to do that. The question is, can we use that historical data and train technologies to help us do this better? We already know they're better at math than we are. Can we find the mathematical operations that will help us with predictive analytics, prescriptive analytics, and maybe one day cognitive analytics, systems that really not just learn certain tasks, but really seem to think with imagination and creativity. So we can really think of this as a nested chart here. I mentioned data is growing. I mentioned people want to know what's going to happen. Companies want to know what's going to happen to make better products, to offer you better products and services, to increase capabilities. And so they've been using data analytics for a long time. Well, the ideas for artificial intelligence have also been around for a long time, but until recently, we haven't had enough data and enough computational power for some of the techniques that I'm going to talk about. Now, some of you on this call may remember that the term AI was actually coined in 1956 in a Dartmouth workshop. And it had a big boom in the 80s with these symbolic logic-based expert systems, which were really kind of like nested if statements. If the user said this, then do this. Else, if the user said this, then do this. And if you make enough ifs, you can make a system that kind of sort of seems to simulate human intelligence. But more recently, some techniques called machine learning and especially deep learning have gained a lot of traction. And these techniques are powerful techniques, and that word learning is important because it allows the model to learn from data. These techniques are inspired by how we learn. We learn from experience. Our eyes collect data, our ears collect data, we read things, we listen to talks like this. We assimilate that information, and that helps us learn so that we have a model by which to make future decisions. We're going to talk about machine learning and deep learning as subsets of AI and somehow get all of that into 15 minutes. But I want to assure you, you've already seen it in your life. If your credit card company called you because they thought it might have been a fraudulent transaction, there was probably an AI algorithm that was deeming that one a risky transaction. Maybe you were buying something out of the ordinary. You see it in your facial recognition to unlock your phone. You see it in your Amazon and Netflix recommendations and more. Now, this is a bit more of a geeky slide. I showed you a simple view on the previous slide. It turns out a lot of these fields kind of overlap. So there's some overlap between databases and data mining and statistics and pattern recognition and AI and machine learning and deep learning and neurocomputing. So when you see these words in the press, don't panic. Realize that everybody has their own definition for some of these fields. The definitions probably overlap, and what's really more important is that you know how to use it. And there's lots of great educational resources for learning how to use it. Now, machine learning and deep learning are really good with dealing with unstructured data, like pictures, like images, video, and audio. And this has really been the driver for the boom in deep learning, which I'll get into. But let me describe the more general set of machine learning. Very simply, and this is the nerd speak on the left and just the high level picture on the right. You take a bunch of inputs and you develop a system to learn from those inputs and give you outputs. It might be images that you want to train something to recognize the types of objects in those images. It might be clicks on web links by which somebody is gauging your interests and creating a psychograph for you. It might be your buying patterns, in which case they're going to want to infer what recommendations to give you that make you most likely to buy something else. So there's an enormous number of inputs, and sometimes there's a very simple number of outputs. But this is the basic path in this. Here's one of the 3 or 4 geeky slides I promised. It is machine learning's in widespread use, and it follows this basic pattern of training a model on the left, and then you develop this classification engine on the right. So for those of you who are already understanding machine learning and deep learning, you've seen this before. For those of you who don't worry about everything in red. That's really for the folks that are in AI. The basic procedure is to collect a lot of real world data and label it for the simplest form of deep learning called supervised learning. Label it and train a model to guess right on those labels. And then you can apply that model in the real world to do what you trained it to do. So again, it's not magic. You're using training data to train a model, and it learns the more data you give it. It learns from that so that it can then be applied in the real world. So with everything I just said, I'm going to ask an easy question. The linear regression that you all did in high school or college, you did it in a statistics class. Is linear regression machine learning? Type your answers in the chat real quick, yes or no. And I have the slide up, so I'll ask Jessica to tell me who's winning, the yeses or the nos. Jessica, I can't hear you on mute.
I unmuted myself. Yeses.
The yeses are winning. The yeses are correct.
I think the yeses are winning. Good job, yeses. High five yourself.
It is absolutely a statistical method that we all learned, but it is also probably the, as a computer person said, the hello world of machine learning, in the sense that you are training a model, in this case, the slope of a straight line, so that you can now use that slope to predict new y values given new x values. Now you can see there's some scatter here. The predictions are going to be probabilistic. They'll be statistical. But you have now trained a model with linear regression to make predictions about the future. Now, machine learning is in widespread use. This is the second of the scary, geeky slides, but some of you will probably recognize some of these terms. There's regression methods, there's clustering methods, random forest, Bayesian classifier, support vector machines. There are a number of methods for training models on data to help you by making predictions or judgments or inferences on the output. And again, it's a two-phase model. Now, the one that you've heard the most about recently is probably deep learning. And that's because deep learning, instead of using the algorithms that I showed you on this page, it uses algorithms that do some very complicated math with these layers of, they're called perceptrons, they're artificial neurons. This technique was inspired by how we think the brain works. And when I say inspire, it's just like when you see the movie that says it was inspired by real events. That means it's not real events, but it's sort of kind of like the way that happens. In this case, artificial neural networks, which are the basis of deep neural networks, they kind of work sort of like we think the neurons in the brain work. And a real simple explanation of this, because I'm limited to 15 minutes, is this. You have these inputs on the left, these images of people. If you train with enough images of people, you can train this network to recognize whether something it sees in an image is a person or not. And that might seem like, well, why would you want to train it whether it's a person or not? Well, you might be doing surveillance in your retail store and you need to know if there's a person on aisle 3, which is where the expensive electronics are, because maybe you don't have a security guard on duty. So you can train it with lots and lots of images and train it to recognize what you've labeled in those images. You can do it with lots of images of the same person, and then you get a model that does facial recognition of that person. I'll give you one of my favorite examples so you understand the strength and the weaknesses of this very simple form of AI that is object classification. NVIDIA has a great AI podcast, and in episode 1, they talk about an engineer who wanted to prevent his neighbor's cats from coming and going to the bathroom in his yard and turning the grass yellow. But he was a nice guy and he didn't want to confront the neighbor, and how's the neighbor going to control the cats? So he trained an AI to recognize cats and cut his sprinklers on. So he had a video camera trained on his yard, and if it saw a cat, it cut his sprinklers on and the cats would scurry away before they had a chance to do their business. He trained it on images he got off the internet, and it worked about 67% of the time. Think for a second, why would it only work 67% of the time? If you trained a human on what a cat was, a human would recognize it 100% and turn the sprinklers on. So why was the AI less accurate than a human? If you think about it, he trained it off images from the internet, and all the images that he got on the internet at first were cute cats. Cats playing with balls of yarn, cats sitting on pillows, cute cat pictures. And he realized, I didn't train it on real world data. I have to train it on cats walking and moving and slinking around. So he found more images and retrained his model, and then it got up to 90+% accurate. So again, AI is not magic. It's very powerful. it replaced having to have a human watch the yard 24/7 for when a cat came in the yard. And now with a simple little device, he had trained a model that he could deploy. It recognized cats and it cut his sprinkler system on. And that's really the power of deep learning. It finds patterns at all these different scales, the scale of the whole face, the scale of the nose, the eyes, the ears, the mouth, etc. And it's way too complicated to go into in a 15-minute overview, but this deep neural network allows it to identify features, and then you're training it, you're grading its success or lack of success. That assigns weights to these connections, and in the end, you have a model that has this recognition capability. Now, it's not just about images. It's about recommendations. It's about fraudulent transactions. It's about all kinds of things. And we're seeing all branches of industry, as well as government and education, adopt it. This slide is just a tiny, tiny set of the kinds of things that people are doing with AI. It's only a tiny number of the domains and a tiny number of the problems within those domains. I really just wanted to give you an understanding that this ability to train models on real data and then have those models do the work of humans is really powerful. And again, just as calculators and computers are much more accurate than us, they're also much faster than us. So now you can train models and deploy those models at scale in the world, and they can go make these decisions for you. Autonomous vehicles are where one of the holy grails of AI. And now you probably have an understanding of what that autonomous vehicle is doing. It's got lots of sensors on it, cameras, and also LiDAR sensors, which humans don't have. And it's constantly sensing the environment around it. It's been trained on what stop signs are, what speed limits are, what pedestrians are, what other cars are. And now it's making constant real-time decisions based on evaluating its environment. And as we train these autonomous vehicle test cars with more and more real-world conditions, including some of which we simulate, we fake and give it simulated, visually realistic conditions, now we can train it to recognize all the things that a real driver might recommend. So some basic takeaways from this. I realized that was AI in 15 minutes. I hope you understand that AI is a set of techniques. It is transformative and it is revolutionary and it is disruptive, but it's also the natural evolution of our desire to understand the world around us, to ask questions about what will happen next, and to try to understand how we can influence what will happen next. And machine learning is this currently dominant subset of AI that is yielding so much promise, driven by the fact that we have so much data. This method doesn't work if you don't have good data, but machine learning methods, and especially the deep learning methods, when you have lots of good data, they can learn from that data and be trained. And they can be retrained as you get new data. We would call it new experiences. The system just sees it as new and more data. And now you can boil all of that experience down into a simple model that can be used to make classifications. And this was all enabled by the big data era. So that's why I started my AI talk with data, not AI. As we have more data and more powerful processors, we can use these really powerful algorithms to do some amazing things. And so deep learning is particularly powerful when you have lots of data, especially unstructured data. It's hard to write a computer program to read someone's handwriting without a deep learning technique. But with deep learning, we've found ways to recognize handwriting and even to understand the semantic meaning of what it is read. And the real final slide here is this: artificial intelligence is a journey. The AI systems we have right now are relatively simple. We train them on data, or we allow them to train themselves with a set of rules. We're into the era, even on this slide, of reinforcement learning, the fourth row down. We do have AI techniques that can punish themselves and reward themselves and get better and better on their own. But the real future is neuroevolution and cognitive computing, and we are nowhere close to that. So even though we started at the top without computers, and the entire process of determining the question and knowing the answer and making the decision was all humans for the longest time, for the last 70 years, We've been working through some of these additional layers in this. Computers invented about 70 years ago, machine learning techniques shortly thereafter, deep learning techniques shortly thereafter, deep learning really booming in the last 8 years. And now we're starting to use some more advanced techniques like reinforcement learning. So with that very accelerated intro to AI, I'm going to turn it over to Charlie Burgoyne of Valkyrie. He's the CEO and founder. He practices AI every day in their company. So let me turn it over to Charlie. Welcome, Charlie. And Charlie's going to bring up his slides. Charlie, you're still on mute.
Thanks, Jay. Appreciate it. Give me 1 second. Let me see if this all fits. I go to play mode. You guys able to see my deck? Get these things.
Yeah, we were able to see it. Looked good.
Great. Okay.
Yep.
Yeah. So as Jay said, my name is Charlie Burgoyne. I'm the founder of a company here in Austin called Valkyrie. You can think of it as a modern day Bell Labs. So we're an applied science firm that touches all sorts of different types of artificial intelligence, quote unquote, machine learning applications and such. I'm a physicist by training, so excited to see Dr. Wheeler on the call today. Really have admired UT Astro for a while. I came from a theoretical Astro in grad school, and variety of backgrounds in the applied science space. But I want to dig right in because this is a domain that I think has been commandeered, bastardized, charlatan, infuriated. And I want to be really intentional about what is intelligence, what is artificial intelligence, what is machine learning, and why have we not seen some of the implications, the promised implications in a period of time. And it starts really with a consensus, a challenge that we see with industry leaders, experts, from Elon Musk, who's on the far side of the spectrum, where there's certain death, there's no way AI is not going to come in and kill everybody, to Ray Kurzweil, who's on the far other side, who's super excited about the enhancement of life, neural implants, and organic and non-organic interfaces. Really interesting side. But none of these guys are agreeing. So depending on who's tweeting what day, you may have a wildly different perspective of this super important scientific field. And progress is super questionable as well. You'd think, talking about artificial intelligence as much as we are right now, that we've made great strides and advancements in the relatively near past. But it's actually a really complicated domain. And the more it gets conflated with applied neuroscience, the less deterministic the value has become. So at its core, machine learning is really an ensembled approach for computational statistics. Not super sexy. Actuaries have been doing this for eons, right? But what we're realizing more and more is that the intrinsic value of artificial intelligence comes from the ability to manipulate data into formats where it can speak with other formats, and then develop pattern recognition systems, algorithms that are largely based on applied statistics. So real quick, and then I'll get right into case studies. Alan Turing, he's kind of the guy in our field, really fantastic scientist. He completes his automatic machine. 2011, Watson wins Jeopardy. Where do you think the algorithms that fed into Jeopardy's success were created? You probably think 2008, 2009, 2010. No, co-reference resolution. It's super simple, or it's super fundamental to Watson winning Jeopardy. Incredible achievement for science technology, but the fundamentals, right, the fundamental components of Jeopardy being so effective were incepted in 1978. How about deep image classifier? So identifying exactly what's going on with Kim Kardashian. How do we identify using convolutional neural networks exactly what's going on in an image? You'd think again, right? Maybe 2014, 15. These are the times where the advancements in these research, various fields of research had that kind of impact to be able to enable this. But no, even earlier, convolutional neural networks were formalized. And you get the picture. We go to another example that you'd probably think is a great exemplification of the power of AI, AlphaGo beating KG. 1987, Monte Carlo tree search was developed. So what's my point? Well, between the fact that we have really confusing authorities on artificial intelligence who are saying wildly divergent things, and the fact that the things that we're championing for advancements in artificial intelligence are actually advancements in high-powered computing, not the actual fundamentals of how cognition operates, leaves us in a position where we're actually still very much in a quote-unquote AI winter. You've probably heard that for the last 5 or so years, that we're coming out of an AI winter. And I would argue that NVIDIA and GPU manufacturers have brought a heat lamp over to us. We're still in the winter, but it feels warmer, right? Because what's really happened is we've gotten really adept at democratizing complex routines and processes that allow for complex operations that we've known about for decades, but we haven't been able to operationalize until now. So to distill it simply, this is kind of the Valkyrie breakdown, although it's been impacted from a lot of different types of scientists that we work with. Artificial intelligence is really comprised of 2 different domains. One is knowledge engineering, and that's really the science and oftentimes art of identifying an ontology or a knowledge structure, and then applying that knowledge structure into a digital space. So whether you're representing data as an Excel spreadsheet or as a complex graph network or as an unstructured document-oriented database, knowledge engineering is the truly hybridization between art and science of representing data in a way digitally that will make itself amenable to patterns that are really valuable for a human. And pattern recognition is the other side of that, right? Machine learning falls in this category of pattern recognition, developing bespoke algorithms that are designed specifically to unearth those underlying patterns in the knowledge systems that you've developed. Unsupervised, supervised, those are kind of 2 derivative fields of machine learning, as Jay mentioned. The industry puts about 90% of the focus on pattern recognition, right? That's all the sexy stuff in AI. Fastest neural network, the fastest GPU accelerated algorithm. 10% of the energy goes to knowledge engineering. But as I'm about to show you, knowledge engineering is super, super important. In fact, at Valkyrie, we've got teams of scientists, physicists, biologists, chemists, mathematicians, statisticians. All we really focus on predominantly is about the knowledge engineering side, because it's actually super, super critical for a comprehensive solution to be developed for clients. And Valkyrie's been, Valkyrie does a lot of different types of things. We have investments, so we have a hedge fund, but we also do services. It's a mix of different activities, all of which depend on a competent knowledge engineering routine. So I'll give you the first example. So we had a client who came to us, a big greeting card company, who asked us, hey, how can we automatically create greeting cards? And that's a pretty wild ask. So first we said, we don't think it's possible, right, to automatically generate content or match image content to text content. But they pushed us, and so we said, okay, we'll give it a try. As it turns out, we matched a convolutional neural network, which was able to identify objects and images, which Jay alluded to earlier with the perceptron visualization, which really is able to, through a process called pooling, distill down complex images to geometric primitives. It's a fancy way of saying shapes and identities that you would be able to recognize semantically. A neural network has been specifically tailored to be able to replicate that ability. It's one of the only things that deep learning does very, very well, is being able to replicate our own semantic understanding of an image. And even that is not as adept as you probably hope. There's a lot of work that goes into making that effective. But we paired that with some natural language processing, where our team took a collection of different scripts and copy, and then was able to extract sentiment, content, and context from that text and match that back together. So in the end, we were able to take a huge corpus of images and a huge corpus of captions and automatically generate greeting cards. And it was pretty eerie, actually, because as you can see, with this image, you'd have a message that said something like, there's nothing like it, absolutely nothing. Wind howling, logs crackling, popcorn popping, beer sparkling, and you're pouring. And what you pour tells you in every sip why it's the world's most famous beer. Its label proudly tells you of the high quality and its ingredients, right? You can see that this is this is a match that a human being wouldn't be able to recognize. It's a really, really interesting exemplification of canonical machine learning or traditional machine learning with natural language processing, and then a more tailored approach for a deep learning problem. We did the same thing with a couple of different examples where, again, we were automatically generating these captions and greeting cards for a firm. And here, automatically being able to caption, using the same technique to basically being able to automatically caption different types of media feeds. Why am I showing you this? Because it's a good exemplification of how important it is to not only have your pattern recognition systems in line and congruous with one another, but also to create your data in such a way that it's amenable to these patterns to be identified. So our copy had to be in a position where we were able to extract context and sentiment really, really readily, and have an ontology that supported the context and content that we'd be identifying in images. Frankly, that was the hardest part. Identifying the objects was pretty straightforward. You can find a lot of pre-trained models that are able to do that really effectively. But being able to normalize that ontology, it's a really difficult human-dependent challenge, actually made all the difference. Adaptive pedagogy. So this is one that's particularly interesting right now, given how many people are probably going to go into remote education in the fall. But years ago, I worked for Rosetta Stone, a language learning company. And it was there we really got excited and focused on the concept of creating a totally adaptive pedagogy, where you're able to create bespoke content and change content depending on which user is using that. We started off with hidden Markov chains, which is a very traditional method for creating phase-based sequential learning. Let's just call it that. But what we found was that residual neural networks also served as a really valuable way for us to embed lots of features about a user as they're going through that experience, and then automatically identify the path through which they can be most effective with the learning. So imagine you want to learn German. Well, if you want to learn German and you're 7, you're probably learning German for very different reasons than somebody who's 70, right? One's probably a child connecting with their grandparents, and maybe one wants to retire in the Black Hills. So in order to make the most compelling product possible, creating an adaptive pedagogy, an adaptive experience where interaction design is actually completely dependent on these frameworks of neural networks is really going to become in vogue. I started the machine learning practice at Frog Design, and that was a major central focus for me, was identifying the right team. I found an incredible, brilliant team who was able to work on these kinds of things, way smarter than I was, who identified different ways we could identify patterns in behavior, extract context from that, and supplant that with adaptive designs. The beauty of residual neural networks versus the traditional hidden Markov chains that we originally used was that we were able to embed with tensors instead of scalars, nerd out for 10 seconds, embed with tensors instead of scalars a variety of latent features within somebody's decision-making process, extract that, and then complement that with an adaptive design. My first day at Frog Design, a top interaction designer asked me if I was going to take his job with a robot. And he was kind of joking, but with a really dry sense of humor, I looked at him totally deadpan. I said, no, but you should be terrified, because if you have like nights or weekends or family or friends or a dog, you're not going to see any of those things anymore because you've been designing for one archetype your entire career. My tools, my team's tools, are going to be responsible for giving you 50 archetypes to design for, all of which are going to be dependent to these tiny perturbations and decisions that they're making throughout the experience that wildly disrupt subsequent stages. So we had a good laugh about that, but eventually he did like lose nights, weekends, family, all those things were gone because I'm just kidding. But it was a really exciting experience for us to create these adaptive designs that were based on these fundamental layers of residual neural networks and hidden Markov chains. This is my last example. I'm going fast as I can because I think I got 1 minute left. In short, we worked with a really cool ISP, an internet service provider, and they asked us how to make their business more competitive by raising prices or taking out competitors. What we realized is that the traffic that they had an incredible amount of value when it was repositioned in a new format from an knowledge engineering standpoint. And so this small ISP that was focused on making more money almost exclusively through charging higher rates in the right markets suddenly used their data for much different applications. They could use their data for defense applications to support their local government. They were able to use their data to support investment decisions. In fact, those are overlapping with some of the directions that we're taking on with the hedge fund. They were able to identify different types of companies that would be good investments for their auxiliary investment pool. All because we were able to reconstruct the existing data they had into a complex graph network. And this is the kind of thing that Valkyrie gets really excited about, because the algorithms that support a complex graph, high modularity algorithms, Levain's algorithm, centrality, eigencentrality, betweenness, all the traversals, all of these graph algorithms actually serve as really logical ways of distilling down how complex relationships are really working. And when applied in the right way, you can define a tremendous amount of business value and extract it seamlessly. So Valkyrie, we do a ton of different types of things: NLP, computer vision, graph theory, applied, adaptive experience design when it calls for that, and then lots of things in different sectors, whether it's financial services and insurance, automotive, and then of course we do our fun stuff on the racetrack. But in short, the reason I'm sharing all this is because artificial intelligence, or what the market appreciates as artificial intelligence, is this fascinating horizontal capability that is absolutely going to disrupt a tremendous number of different types of activities. But I'm more on the Ray Kurzweil side, where I think it's going to be positive. There are a lot of great questions that are popping up around artificial intelligence. I'd love to dive into those, but we constantly are thinking about existential questions about what the nature of knowledge really is. What is it? What does it mean to be intelligent? And trying to disseminate all these different neuroscience esoteric theories that are conflated with all sorts of challenges when empirically put to use. It's an exciting time. Really, really happy to be a scientist, physicist turned machine learning scientist, but it's great. And I'll pass it back over to you, Jay.
Great, thank you, Charlie. And now we will have Kimberly wrap it up by talking about what it means to get into AI and what it needs culturally and what your company needs to do. So I will bring slides back up and I will share Kimberly's slides. Are those being presented now, Kimberly?
Yep, I can see them.
Great, all right, just tell me when to advance.
All right. You guys are tough acts to follow, right? We've got a physicist, we've got a PhD, and then you've got, boring old MBA marketing leader here. But what I do bring to the table is a little bit of a different view, which is the pragmatic view of how do enterprises actually implement AI, or what I like to call digital transformation. And so I wanted to just kind of start off and tell you guys a little bit about myself and the company I work for, and then I'm going to get into some real world life when it comes to digital transformation. So first of all, I have a confession to make. I am a data junkie, right? So I am a runner. I'm a marathon runner who has turned attempting to be a speed runner. And so I live and breathe by Garmin, right? It rules my life. I wear it all the time, and it makes sure that I keep on track. I'm also a stepmom, and so I live and breathe by Live 360 because I want to be able to see where he is going, how fast he is going, who else is in the car, is he following the stoplights and the stop signs, and I'm also a marketer. And so that means I live and breathe by my MarTech stack. I want to know how many leads I'm creating, how those leads are turning into win revenue, are they qualified? And so needless to say, data is just a part of my life. And I think that's why I'm so interested, and I've been so interested in AI and digital transformation over the last 6 or 7 years. And so prior to joining Rapid Deploy, I was actually at IBM. I led marketing for IBM Cognitive Systems, where I was helping enterprises digitally transform for about 5 years. And now that I'm at Rapid Deploy, we are a company that is really trying to democratize public safety and 911. And what that means is we're bringing analytics and mapping and dispatch to 911. And it all comes down to giving 911 telecommunicators and first responders data when they need it most. And so that requires, predictive analytics. It requires machine learning. It requires, integrating a lot of data from a lot of different sources, IoT data in the cloud, and making it accessible to 911 operators in the time where they need to be able to act quick and have a full view of situational awareness. So that's just a little bit of my background and why I find this interesting. But the reality is like all of these guys have been talking about, like AI has been around for a long time, and the hype is real and the promise is real. But in reality, we're not seeing return on investment. So if you want to flip to the next slide, Jay, the reality is 3 out of 4 AI projects fail in enterprises. And so that's not to say that companies that are focused on AI and that live and breathe by AI are seeing this level of failure, but this is a statement, and it's collaborated by great research from Gartner, as well as a study that I did with a lot of about 550 enterprise AI decision makers. But what we're seeing is that 3/4 of these projects are failing. And so while you see investments increasing, and I saw some data a few weeks ago about, big investments in AI from enterprises, they're still not seeing a return on investment. So that's the reality that we live in. And so it's no surprise that people are starting to question the hype, right? Because you get excited, you see all this information, you see these great use cases, you see a lot of party tricks. We talked about, Watson, we know about chess, but we're not actually seeing where that increase in revenue or the increase in business metrics is really happening. So it's an interesting place where we are, which I think is why people are starting to question, like, are we going to see an AI winter? Because ultimately, if we don't start seeing more AI projects being successful, we're not going to actually see businesses capitalizing on those projects. You can flip to the next slide, Jay. So what does it actually take to cross the AI chasm? This was the biggest question that I had when I was at IBM Cognitive Systems. And so I went out and talked to almost 600 executives that are making decisions around AI and investing in AI. And the biggest takeaway that we had from this research is that ultimately, for the enterprises that keep AI strategy, data, technology, people, and processes close to the core and controlled, they see the highest return on investment across all financial metrics that we measured. So we talked to them about the change in revenue that they were seeing, the performance in product and service design. So how quick were they able to react to their customer needs? And then also, what does failure look like? And so organizations that were really trying to take this seriously and make a concerted effort to build a, I call it a center of excellence, but really keeping this core and controlled is where they saw success. And the reason why is because it's really hard, right? It's really hard, especially to work projects that you don't data scientists that are buying servers and paying for software and end up investments that you can't control and you can't measure. One of my clients, who is a big retailer, not a luxury retailer, we'll put it that way, had a skunk work project that was basically an IT guy and a PhD in machine learning who would work together and go and challenge organizations throughout the company to see whether people or their machine learning and deep learning tactics would work. They challenged marketing, they challenged the supply chain and inventory team, and while they saw some project success, they actually did not see return on investment because number one, they weren't able to accurately measure, but number two, they were spending money that the organization was unaware of. So it really gets to this point. So you've got to ask yourself as an organization, how do you keep this core and controlled? How do you make sure that you're making the right investments in not just the technology, but also the people, and that you're providing the oversight that those organizations need to be successful? They shouldn't be out challenging organizations to a hand-to-hand arm wrestle to see what's better, right? There should be a concerted effort to understand the use cases, and to understand how those use cases can actually help the business. And one of the things that I learned in talking to a lot of these folks is that at the beginning, mediocrity and excellence look really similar. So when you talk about my friends at this retailer, they kept saying, well, these projects are successful. Like we're beating marketing. Like our marketing customization efforts through machine learning are, proving to be better than these efforts that the humans can do. And so ultimately that's probably true, but as you look at how that scales across the organization, excellence turns into mediocrity really quickly if they can't scale. And so as I talked to more and more organizations, I started to see those things come out that really enabled those organizations to be successful. JP Morgan is a great example. Obviously, they're a little bit further ahead of the game because as a financial institution, they have a lot of quantitative understanding. They have a lot of HPC, like infrastructure understanding. But they've done a really great job of building a center of excellence mentality that extends from data science to IT to the executive ranks. Something else I think is really interesting about JP Morgan that I always like to mention is that they have a lot of women in machine learning or AI type of leadership roles. They have a woman CIO, they have a woman leading the research center, they have a woman who is up a lot of the machine learning efforts, they have a lot of diversity in their data science organization. So I think they've done a really great job of building that core competency, but also thinking strategically about how diversity plays a role and how diversity can help them in terms of thinking about the long-term gain versus the short-term wins. Another great example of an organization that was doing it well and thinking through use cases really well was Walmart. They had some pretty creative use cases that they were using on the supply chain side that they shared with me, talking about how they were able to use machine learning and deep learning technology to be able to better predict the inventory shortages and how they could leverage the ability to fill their shelves at the right pace with the right content. And what I thought was interesting about Walmart is that they really did, they took the use case development seriously. Sometimes you talk to these enterprises and you literally feel like they've gone out and they've Googled best machine learning use cases for X, Y, and Z industry. And they're just trying to, and I always say, like, if an organization, an enterprise is still trying to figure out their use case, then that means they haven't really gone far enough to build that core competency. And that's kind of the first step in that process. So if you want to flip to the next slide. What this means is that in order to drive measurable results, it really takes an organizational structure, it takes a collaboration model, and it takes technology choices. And if you think about it, AI adoption in an enterprise is, not all that different than when we adopted cloud technology. It's not all that different than when you adopt a new ERP system. Yes, the technologies are different, but the amount of change management and organizational implication is huge. And so I think it's really important as you start to talk to enterprises that are making this transformation, that you don't just talk about the technology piece. I think what I'm starting to see now is that people understand the technology piece, because you've got great people like Jay and Charlie who are out there, talking every day with enterprises and talking about the decisions that they need to make from a technology standpoint. Software, frameworks, servers, cloud. There's so many discussions that happen at that level, but what discussions are not really happening are how do you build a collaboration model and how do you build an organizational structure that actually drives the return on investment. I've seen some research lately that's come out that talked about CEOs now driving the AI mandate, which is interesting because a year ago we were kind of talking about like how does the line of business leader, maybe marketing, maybe procurement, maybe something else who is seeing that value, work together with IT and with data science as this functional team. And what it looks like you're starting to see now is that collaboration model is breaking down so much to the point that CEOs are stepping in and saying, I've got to lead this charge. And while I think it's important that things are getting bubbled up to the executive level and that AI is an imperative that comes down from the top, I also think it is dangerous in terms of the, breaking that collaboration model in that it comes all from the top, right? So I think it has to be a strategic imperative. I think that the executives have to embrace this change and the transformation. But I think ultimately, if you don't have this being co-led between IT, line of business, and chief data officer, or whoever's running data science, you will fall into a lot of challenges when it actually comes into implementation. So I was disappointed to see some of that data recently, because I was hoping, based on the research from about a year ago, that we were going to see a lot more of that collaboration and those three silos being broken down, instead of having to go all the way up to the CEO. But what it says is that people are still trying to figure out that org structure, or that collaboration model, and they're still not seeing those results yet. If you want to flip to the next slide. So a couple of thoughts, and this is just ways that I think about this and how I've talked to enterprises and clients about what to think about when you're building an AI center of excellence. And number one is business orientation, right? How do you focus on more ways that you can positively impact your organization, more use cases than just isolated one-off experiments? This kicking the tires is fun for a while, but it ultimately will not drive ROI. So you have to have that business orientation. You've got to be thinking about that cross-team collaboration model and make sure, and this is where, like I said, I get a little worried about it coming straight from the top, is because if you don't have that collaboration model, you can't make sure that it is easy to implement and easy to measure, and that you can actually scale. It's really hard to go from production to scale, and without a collaboration model, you just won't get there. Having that coherent information architecture approach, obviously, Jay and Charlie are probably much more, able to talk to the details around what that means, but making sure that people have data access and there's governance and you've thought through privacy, all of that is really important, and it starts with data. Having the on-prem applications and infrastructure plus the in-house skilled resources, I think is really important as well. It doesn't necessarily mean that you have all your infrastructure is running on premises, right? But it's making conscientious decisions, having that talent, having the ability to understand when you have to run something yourself versus when you can use something in the cloud, and being able to ensure control and manage costs appropriately. Bias oversight. I know this is going to be much more of a topic in the next session, but I think as you think about building an AI center of excellence, it's really important to think about how that center of excellence can help with bias oversight as well. You want to be proactively thinking about it, whether that's, from what I was talking about before, building a diverse team and having that talent that represents all the people that you're trying to serve, but also making sure that your data sets and your algorithms are thoughtfully produced, and that ultimately you've got that oversight committee that feels comfortable to say, yes, this is a flaw, let's go back and relook at it and train again. And then ultimately, documentation of process and rules of engagement is really critical, and that's what really drives ultimately scale and repetition. And if you don't start having those documented processes, when you lose talent in the enterprise, you lose a lot of that institutional knowledge. And so I've seen a lot of companies who felt like they had a decent collaboration model, a plan for production and scale, but who ultimately lost critical talent and had trouble figuring out how they were going to actually drive that through to ROI. So that, in summary, is really what I wanted to talk about today, and kind of go from the technology to the real implementation, because I think ultimately the biggest challenge that we face is culture and strategy, and the technology we've made such huge progress on over the past few years, but also many years before this. But I don't know that we've spent enough time thinking about collaboration and how we actually drive return on investment. Because if we don't start showing that return on investment and the ability to move from training into production and scale, we're going to be very challenged to not find ourselves in another AI winter, I think, from an enterprise standpoint.
All right.
So great.
let's jump to the Q&A now. Thank you, Kimberly. Thank you, Charlie. There's a lot of questions in the Q&A button. So I introduced Navira Abbasi from Galvanize. She is going to, and I misspelled your name on the slide, Navira. I got the number of B's and S's mixed up. Sorry about that. Navira is one of our advisory board members, and she's going to moderate the Q&A. We are going to wrap at 7:25, 7:26, and then come back for extended Q&A. So if you are planning on this event ending at 7:30, we will end at 7:30, but then we will have an extended Q&A session. So with that, Navira, take it away, and I'm going to ask my co-speakers to use very concise answers so Navira can ask lots of questions.
Awesome. Thank you, Jay, for the intro. So I'm going to hop around a little bit to make sure we have a good balance between questions directed at Kimberly and at Charlie. So I'm going to start with some questions directed at Kimberly first. So could you provide us some examples of enterprises that aren't data mature, like a bank or Walmart or a startup, that have been successful building AI practices? So I guess the question is, can you build data maturity and an AI practice simultaneously?
I think it's hard. The reason I say that is because real investment in AI from an enterprise standpoint, right? Again, I'm really talking less on the research and like technology piece, but more on embedding it into an enterprise, requires a pretty sophisticated mindset and a pretty decent amount of money. Let's just be honest. And so where we, at least in the work that I've done, and maybe the others can talk to working with smaller organizations, is that smaller organizations, while they were more ready to adopt emerging technologies. So you didn't have the same change management challenges as you have in the larger organizations. I found that they, without having a pretty strong set of legacy data, right, which is where you see retailers and banks and manufacturing, they have a lot of data to sift through. And so having that data, having already having a kind of an architecture approach to how they manage that data, as well as having a pretty decent sized budget, was where I was able to really see people that were able to move pretty far along. Now, that's not, to me, again, like I said, there's a lot more ability to deal with change management and adopting emerging technologies. But I think, at least from my experience, I saw that it was the larger organizations that were really able to really invest in that center of excellence and building that core competency.
Awesome. Thank you. I'm hearing you need lots of money and planning. Next question, I think, is somewhat directed at Charlie, perhaps, which is, when will AI be able to answer what is the meaning of life? And I think what this question is getting at is, when will it be able to pass some type of like Turing test, or when can we get something like an ex machina AI intelligence, I believe is what this question is aiming at. But yeah, I'm actually curious about the answer as well.
Yeah, it's a common question. The further I get in this field, the less convinced I am that a generalized intelligence derived from a digital capability is tenable. I don't currently see the progress in even our basic understanding of cognition availing itself well to digital replication, to be able to capture the exciting stochastic things that exist for us to be human, channeled into a format that can exist inorganically. So I guess more fundamentally, the meaning of life may actually be the same question as, what does it mean to be intelligent? And given the fact that that is a question that the further we go, the less we know, truly, it is something I've had to reconcile for my own career, to never find the answer to that, but to find value from the incremental steps that we'll make towards that dawning moment. Does that make sense?
Navira, I'm going to provide a little bit of a counterpoint to Charlie on that. I hear what he's saying, but one of the most true things about humanity is that knowledge advances exponentially. Byron Reese wrote a great book that came out a couple years ago about the fourth revolution, and he did a great historical context about how knowledge was very slowly growing for millennia and then centuries, but it's growing exponentially, and that's a incredible capability. So it's difficult to predict the future, and humans are terrible at predicting the future and what the results of compounding exponential advances in multiple technologies will be. So I kind of agree that it seems right now like it might be infinitely far out or a really, really, really long way out. But our brains manage in 13 watts with a bunch of chemicals to do some pretty amazing things that we can't replicate in silicon for sure yet. But the brain stays the same year after year after year, and our exponential increase in technologies mean that, you know, we couldn't even have conceived of that 20 years ago, of having computers that can do what they do now. And in 20 more years, I don't think we're really good at predicting some of the changes they will make. And quantum computing and some other technologies, neuromorphic computing, et cetera, may provide some step function increases in capability that, while not mimicking biological intelligence, may exceed it in many ways that we find hard to distinguish from it.
Well, here's a question about today's society, right? And that's about facial recognition. Here's a question from Polina, which is, you know, we talked about computer vision at some point in this conversation today, but what happens if someone's wearing a mask, and facial recognition, as you see in movies, it's a fake cover for who they really are. So how does facial recognition come into play in a time where we're all encouraged to wear face masks? And we probably will wear face masks for a pretty long time. So where does that computer vision facial recognition come into play, especially for security purposes? As was mentioned earlier, that's a big component of using AI, right? Is a champion for security. So any thoughts around that?
It's probably, Charlie, this is probably best for you, I think.
Yeah, I think if you, it depends on what the genesis of the question was. If the question is, should we be concerned about civil liberties and protecting privacy with the advent of adept object detection and through computer vision, I would say absolutely. Sure, there are instances where adapting algorithms to retrain on new objects, on new quote unquote geometric primitives, is becoming much, much easier. In fact, if you could name an object, and within a couple of hours, you could probably gather enough images to train a neural network to identify that, including people wearing masks. But I actually think that in terms of the things that people should be concerned about from a big brother standpoint or from a privacy standpoint, it's the conflation of multiple different domains of data aggregated into a single perspective of an individual or of an object, i.e., it's less concerning that they're going to be able to identify that it's me with a mask. It's more concerning that they may think it's me with a mask from a computer vision standpoint, but they've also been able to geo-reference my phone from my location. They've been able to recognize my voice using NLU techniques and NLP techniques from publicly available microphones, and merge those semantically congruent objects into from different domains into one discrete object. If that's where that came from.
It's hard to understand, or from that question, it's hard to discern where it was coming from, but I think you answered the spirit of the question. Which brings me to another topic that I think we're all worried about and thinking about a lot these days, which is, can either of you address the concerns that AI automates and embeds racial bias within its algorithms, and that it perpetuates systematic racism?
So, I mean, I'll take a stab at this one a little bit, and then I'll pass it over for more of the technology answer. But I think absolutely, we have a challenge of potentially creating systems of discrimination with our AI, and I think it stems from a couple of problems that I was mentioning before, right? It stems from a lack of diversity in talent within those organizations. I think it stems from bias in data sets and where that data is coming from. And then there's obviously, bias in the algorithms that are created. And I think, one of the challenges that folks have right now is that they don't want to admit that there's bias. And we know there's bias everywhere, right? Every individual has bias. We're likely creating, algorithms and data sets that have bias. But, we're scared to actually call it bias when we see it. And so I think the organizations that I've been working with that seem to be making bigger strides on this front are the ones that are catching the bias and feeling comfortable raising their hand and recognizing it, and feeling comfortable going back to the drawing board to figure out where the problem is. And but I do think that having systems of discrimination is a big challenge. And actually, Charlie and I did a keynote at GM Innovation Week. I guess it was last year, where we had this exact conversation. So I know he's got a flip side to my beliefs around systems of discrimination.
It's not quite a flip side. It's just the acknowledgement that statistics are statistics, and that the biases, which are pervasive within these systems, are indubitably embedded because of the biases in the way these data are collected predominantly, and then also certain descriptions that are provided by the scientists composing those algorithms. So in other words, it's a double-edged sword, right? On the one hand, you want to minimize as many biases as possible. It's also pretty much impossible to have an intelligence observation that isn't dependent on preconceived biases. So biases aren't always a negative thing. You actually depend on them for making inferences. But the real challenge is identifying this and the sourcing of data, preparing those data in a way that will avail themselves to be objective. Well, not even objective, because that's impossible, but to provide a sensitive observation, or one that is clearly articulated and delineates where those biases have been introduced. That really should, removing the biases is impossible, and it's actually not even valuable. What we really should be focusing on is understanding those biases, embracing them, and identifying different ways to tweak those, either through perturbations in the ways algorithms are weighted together, or going through the process of aggregating data with a different nuance.
Thank you. Switching gears a little bit on the topic, what is the general forecast for machine learning and AI to perfect autonomous vehicles?
And we have to make this the last question and quick, so Jessica and I can close it up. But again, we'll come back for extended Q&A as soon as we finish the last slide. So Charlie, you want to tackle that one?
Yeah, I'd be happy to. So there's some common technologies that I think you'd be not surprised by. So computer vision is absolutely central. NVIDIA creates a specific device that's oriented directly for computer vision training and testing. Basically, Ford and Daimler have bought all of them. Can't get your hands on them for other applications. But I think the actual really interesting challenge, and this is one that's kind of in our team's wheelhouse, is thinking about the application of graph theory for networks of intelligence, network intelligence and decision making. So everybody focuses on the problem of if a Tesla's coming up on the street and they see a brick wall on one side and a school bus on the other side, it has to decide if it's going to kill the passengers inside the Tesla or kill the kids on the bus. And the folks who are from the mesh intelligence field, and it's a discipline that I ascribe to, contend that decision really shouldn't have been made if other vehicles within the area have been properly instrumented. In other words, you never turned right on the street that was going to present you that decision because 10 other vehicles already got exposed to the dynamics that would eventually lead to that decision, and a new decision was made for you. So that's why a lot of these compute systems that are getting introduced for autonomous vehicle design are introducing the ability to have like 10 NICs or 10 network interface chips that are designed specifically just to be able to manage this super complex mesh network of intelligent prognostication.
Thank you. It looks like we are out of time. Jay, I'll let you take it over from here.
All right, great. And as I mentioned, we will come back and answer questions in just a few minutes, but we promised a 7:30 close. It is 7:30. So real quickly, I want to invite everybody to join us in 2 weeks. The conversation in 2 weeks will be less technical, less business oriented, more humanity and society oriented. So we'll address questions like bias and whether that promotes discrimination and how you can train that out of systems. We'll address issues like health and longevity and how AI can address that. So we hope you'll join us again in 2 weeks with Matt Sanchez from Cognitive Scale, Jean-Lee Nyoroge from Dell Technologies, and Dave DiCaprio from Closed Loop. We have a lot of great events coming up. So in addition to that sort of kind of part 2, but the more humanity and society oriented side, we have 2 events in August on that topic of tech and racial injustice on August 4th, and racial equity in tech on August 18th. This is a huge topic in our country right now. We're seeing lots of, I think we'll all agree, positive changes and positive attention to these issues. It doesn't mean everything will be solved overnight, but we're seeing rapid awareness increases and some rapid changes. We're going to talk about it just from a tech angle in the Austin Forum. So the first event will be on how you can use technology, data, and analytics, such as AI, to promote racial justice, to shine a light on racial injustice and promote racial justice. And then on the 18th, more about how you can promote diversity in the tech sector itself through education, through fair funding mechanisms, through proper cultural support and sustainable culture inside of companies, et cetera. Then we have an event, Tech Startups and Innovation, on September 1st. And our final new event to the schedule, we have an event on online worlds on September 22nd. And that is also a reaction to the times. We try to adjust our programming to be relevant to the issues that are facing society. And so we will even change the schedule when a situation like a pandemic happens, and when things like Fortnite are creating multiverses in which people are not just gaming, but they're watching concerts and having business meetings and such. So that is another new event to the schedule that you may not have seen yet already. Several other great events culminating in our Tech for Social Good event at the end of the year. Quick reminder, you can carry on these conversations on the Austin Forum Slack workspace. It's a low traffic workspace now, but we plan to ramp it up in light of the popularity of the AI topic and the topic's popularity for next month as well.
I promise if you join the Slack workspace and you're asking AI questions, Jay himself will help answer them. So if you have any questions that don't get answered, put them on the Slack workspace and Jay will answer them personally.
Or
with emojis and GIFs also.
That's right, with whiskey emojis. So we also encourage you to donate devices. In these times, we've been more aware of the digital divide than ever before. We've been supporting the Austin Pathways Project to reallocate used devices to people in need. Maybe they have multiple kids who need to access online school materials. So we've got great information on this slide on how you can donate, or you can arrange the donation yourself. And finally, join us on Twitter, Facebook, Slack, LinkedIn, and Eventbrite is where we advertise our events. Please share the events with your colleagues coming up. We love having folks on these. The more people we reach, the better. Now that we're online instead of in a physical environment, we can reach effectively an infinite number of people. So please share the events. And with that, thank you for joining us tonight. Grab a drink and stick around if you wish, and we'll do live Q&A next. So Navira, can you stay on for a while longer?
Sure.
Questions? Charlie, can you stay on for a little longer? Kimberly?
And I would like to say
I gotta run.
You gotta run. All right, Charlie.
I'm sorry. Thank you guys. This was so much fun. I really appreciate the forum here and the great questions and the great dialogue. So I look forward to engaging with you guys more. This was great.
Thank you.
Thank you, Kimberly.
Thanks, guys.
And I will be, as we continue the Q&A, we can make it more live. So I will be promoting people, quote unquote, to panelists, so you can actually have your face seen and engage and have dialogue too. Jay ran real quick to get that whiskey. He's back.
Let's talk AI.
Navira, you're doing an amazing job moderating. So if you want to pick some more questions, I don't know.
Sure.
If you don't have a
so here's another question. I guess this is like, who's policing the police? So what about using AI to inquire/investigate machine learning to validate its decisions and results?
Sorry, can you say that again, Navira? I want to make sure I understood that.
Sure. So the question is, what about using AI to inquire/investigate machine learning validate its decisions and results?
What about using AI to validate machine learning?
Yeah, so the way I'm reading this question is like, how do you police the police in a way? So, you know, if you're using machine learning, like who is validating that whatever machine learning is coming up with? Can you use AI to validate or investigate machine learning? I guess it's like a cyclical.
Yeah, I
What if you use AI
understand.
to acquire?
So, yeah, so as Charlie mentioned, and as I mentioned in the opening, you're training these models, usually training them on ground truth data that you believe to be true or know to be true, or you're training them within a set of rules where you've defined the rules. More common cases on some data. So you validate it on some data, and you take some known data, train the model, and then you test that model against other known data before you release it into the wild. So before you ever start assuming your model is going to be accurate or unbiased or give you the results you want, you test it on known data as well. You train it on known data, and then you test it on known data. And then you should continue monitoring its accuracy in real world environments. Because again, it is not magic. You're using data to train a model. If it sees entirely new kinds of data, it may not give you a very good answer. And you need to be monitoring for that if new data is coming in that's very different than what it's trained for. You also want to be monitoring for bias, for discrimination if it affects people, or any kind of bias. And so, whereas we've talked a lot about machine learning and deep learning tonight, never forget the value of other forms of data analytics like statistics, for just taking statistics on the kinds of answers it's giving you and seeing if any statistical biases are creeping in or anomalies are creeping in. So it's super important to not just build it and forget it and assume it's perfect, but to continue to validate it against real data, especially in changing times.
Awesome. Thank you for that. My next question, I think, is a classic question about AI. And Charlie had this slide at the very beginning that showed, you know, on one side, you have Elon Musk in the extreme, and you work your way down the funnel, and you have other people who are cheering AI. So this question, I'm going to group it into this one question, which is, what is the risk to humankind as you progress down the AI stream? So I guess.
Yeah, so there's kind of two ways to answer that. There's one that's based on sci-fi thrillers, and I think those particular types of questions are pedantic. But the question of what will be truly disruptive and terrifying about the power of machine learning in an applied way, I think is actually super interesting. So for the last 150 years, Western culture, and particularly American culture, has been very adept at creating stepping stone career paths for individuals to traverse socioeconomic layers, right? Your parents didn't finish high school. You finished high school. Your child goes to paralegal school. Their child goes to law school. Their child is a judge, right? So traditionally, the liberal arts system that we've created and unique things about American philosophy have allowed for that traversal to happen. What artificial intelligence does that is incredibly unlike, even the looms that created the Luddite revolution. This era actually does a very effective job at dismantling some of those stepping stone professions. Some of the not blue collar, not white collar, but we can call it light blue collar jobs. So we're going to start seeing prominent attorneys and law firms remove a lot of jobs in the administration space, in the paralegal space, in favor of automated systems that can perform complex diligence and source a variety of different types of legal documents extremely quickly. Physicians will be in the same position where they'll be able to automate the transport of EMRs, onboarding new patients, lots of different types of things through a machine learning application. And my biggest concern, frankly, is that without those roles to be able to traverse different socioeconomic systems within the United States and other places as well, that we are fundamentally breaking down opportunity for subsequent generations. So how do we counter that? How do we think about the implications of that? Well, artificial intelligence, as it's being applied, is still in enough of an infancy that there are multiple ways, lots and lots of ways in which people can get involved with the technology, even if they don't come from a technological background. A lot of people are worried that semi-truck drivers are going to be completely obfuscated because the need for them will be removed because we'll have autonomous driving. Well, we're many decades away from that being really fully tenable and, more importantly, improved by DOT and similar organizations around the world. So that means actually the truck drivers will still need to be in trucks. But what's more interesting is that because of telecommunications and adept tools that are at their disposal, they may be able to have a second job while driving a truck, right? That may be a compromise that we see. So, you know, the evolution of the job space is what actually concerns me the very most. And it's not the folks that we've been traditionally paying attention to as we ebb and flow out of a AI fall or winter. It really depends on who you ask. I think we're solidly in a winter still, but still that has, you know, major implications for these professions.
So I guess a add-on to that question, which will answer another question in the Q&A, is so what value do humans ultimately offer in all of this? AI can do a lot, machine learning can do a lot. And as we continue to see AI progress, what can you speak to and say, well, this is something that a machine will never be able to replicate, that strongly remains in the realm of human value?
The value question is interesting because who defines value, and that's human. So I think that we're going to define ourselves to be of value regardless. And we think of AI, we need to remember that just as it's an amazing technology, but we've invented lots of amazing technologies relative to what existed before them. And some of them have destroyed jobs while creating new jobs, and we've adapted as a species. So we're always going to make tools. AI is another tool. It's a tool that serves us. It might be the first tool that actually can outthink us, unlike everything else that we had to tell it what to do. The calculator is more accurate and faster, but we have to tell it what to calculate. AI is the first digital technology that you can start giving it data and it can start learning and making inferences based on what it's learned. Humans still played a role in that. We figured out the algorithms and continue to research newer and better algorithms. And as Charlie said early on, I'm an eternal optimist on these things, but we are so far from the human brain's capabilities that nobody, even the naysayers, think that an artificial general intelligence is going to greatly outpace all of human intelligence and creativity that the brain offers on any short, our lifetime life scale. An important point is that where human capabilities are the same year after year after year, innate biological capabilities, the AIs get smarter and smarter, and they gradually get better at doing some things, including things we didn't think they would get better at. A great documentary, I don't think anyone listed as their favorite AI movie, but the AlphaGo documentary was a wonderful documentary because people thought no computer could ever master the complexities of the game of Go with its huge number of possible outcomes. And, it ended up beating the world champion 4 games out of 5, and the one it lost was on a bug. So we now realize, oh crap, we've now trained the AIs to be even better than us at something we thought it took human creativity and ingenuity to be great at. But that's more the exception than the rule. There's a vast number of things that it's not very good at, and we see evidence of that. It's really good at dealing with certain kinds of data and predictions, like it's good at reading language. It's pretty good at translating. It's pretty good, not great because it doesn't get colloquialisms and stuff. But have you ever seen computer-generated poetry, or worse, AI-generated screenplays? They are horrible because it lacks some of the things that, as Charlie said before, we still don't understand about our own brains. We appreciate them and we subconsciously use them, but we don't know how they work or why that means what it means. And so we can't develop an AI to replicate it. So we're so far from understanding human intelligence thoroughly that we can't make an AI that outpaces all of human intelligence because we don't know how to program it. We don't know how to fully characterize our own intelligence.
I guess that leads into my next question. You mentioned Go, and so I'm curious about this, the answer to this question. I think it's more directed to Charlie. So thinking about the game Go, right? And you think about investments, and people can say, well, when you make investments, you could say this is a very black and white case of like what makes sense to invest in, what doesn't make sense. At the same time, other portfolio managers and big investors can say, well, there's like a softer human touch that's needed to really understand the nuances of what makes a good investment decision. So I think this question is for you, Charlie. How much does AI execute investment decisions in Valkyrie's funds, and how well does it perform?
So there's another question that popped up that kind of overlaps with that. The question was how can startups be effective against gigantic companies that have a chance? Our hedge fund is successful specifically because of our ability to be much more flexible than much larger funds, to be totally candid. The fund itself does not execute on trades autonomously. That's still governed by the direction of our fund manager. But what the machine learning is currently tailored to do is identify patterns of relationships between financial entities. I have to be pretty cryptic about that, just because of what we're doing. But in short, we're identifying underlying relationships of different types of businesses and how those things are expressed publicly, but quite subtly. So the machine learning doesn't come in to make decisions about how much to invest in and when. The machine learning comes in to give us a unadulterated perspective on the interconnected nature of different industries and verticals. Yeah, so that's a little bit about, there are some folks, Renaissance Financial is one that pops up where they've experimented with different ways of having fully autonomous trading platforms. Some of the HFT guys, the high frequency trading guys, had gone down the path of creating automated decisions, for obvious reasons that are algorithmically derived. Our approach is quite a bit different than that. Our timescales are very, very different from the high frequency folks. Much slower and much more dependent on aggregating variety of domains and then using knowledge engineering to reconcile that into a singular perspective. Let's put it that way.
So it sounds like it's generally giving recommendations on general trends in certain industries or commodities or so forth, and then you can use that information to fine tune the actual investment itself.
That's right. So an analog, because I hate to be super cryptic, but here's an analog. One of Valkyrie's first blips on anybody's radar, not that we have tons now, but one of our first blips was the prediction of the 2016 election, where we gave Donald Trump about a 48.5% chance of winning the election. Now, some of my colleagues, including a guy named Nate Silver, who he and I go way back in rather competitive nature, mocked us for being that prescriptive about his chances. But as history would show, we were the ones who had the field day for the rest of the week from a scientific perspective about the accuracy of our models. How did that work? Why were we as close? We missed 2 states, basically. Why were we so close? It's because that we basically identified at detail which polls were scientifically sound and dependable, and then we eliminated the 85% of the polls that didn't fit within that pretty rigid rubric. Yeah. We then created machine learning algorithms that would create sister states, you can think of that way, so that we could use as proxies the good data from polls. Basically, we created this interconnected network of states, counties, voting districts that all depended on the strongest and source of that connection and the best data. So for example, we looked at West Virginia and Idaho, and guess what? West Virginia and Idaho on paper look really similar. Similar demographics, similar industries that are preeminent, similar reactions to economic deviations that we had to engineer all these features to get to that point. And then we used, I believe it was West Virginia's data was a proxy for Idaho's at certain county levels. It actually had a difference at scale for the entire state, but at the low level, we were able to, anyway, doesn't matter. That approach is not dissimilar to some of the things that we're doing on the hedge fund side, where we're using proxies as representations of actions on different.
Oh, very interesting. And you'd
Now,
also,
will you tell us what you think for the next election, though? I have to interrupt that question. Charlie, have you guys done anything? Sorry, I'm just jump in there. How's 2020 looking, Charlie?
I'm going to drink whiskey.
I'm nervous.
When he answers this.
No, maybe we shouldn't answer this question right now.
So, the complication truly are the externalities this year. COVID presents a major perturbation to any effective polling and modeling right now. So, you know, we don't want to be too prescriptive, certainly this far out. But if you compare this week, this year to this week of 2016, Hillary was actually outperforming Biden. So if all things are equal from here on out, then Trump has again, a good chance of winning the Electoral College, but not winning the popular vote.
Thank you. Just had to ask now that I know that I can ask you about this regularly. Carry on. Thank you, Navira. Yes, this is great.
Sure, absolutely. So this is a job-related question. Do you think the supply of data scientists / machine learning engineers will overpass the demand for them in the near future?
You know, I made the argument before that humans are pretty bad at predicting the outcomes of exponential change, which is, it's not a ding on humans. I mean, if you haven't seen something before, you don't know, it's hard to predict what's going to happen and when it's going to happen. I do think that market economics are such that eventually, sure, that is bound to catch up. Just as, I mean, eventually you have enough people, if you have a glut of people, then the salaries go down and people start doing other things. So I think we're still years away from having a real data science, or many years away from having a real data science workforce. And Navira, your company is great at helping to address that gap. But I think that gap is years because we're seeing such exponential progress in the fields that are using data. So it's not like there's a fixed number of jobs that need data scientists and we're rapidly filling up to that mark. We're seeing a transformation in the workplace, as we've seen throughout human history, where there's a decreasing amount of manual labor and an increasing amount of intellectual labor. And increasingly, as I showed in the graph at the very beginning, as we have more and more data, we're looking at higher levels of data analytics to not just show what happened yesterday, but what might happen tomorrow. And Charlie used a Kardashian, so I'll use that as an example. You know, the company doesn't just want to know how many red shoes it might sell in third quarter by looking at third quarter of last year. It wants to factor in all these things like Charlie was talking about factoring into his models, including what if we could get a Kardashian to tout our red shoes on social media? How much would that change our sales? And so it's really difficult to predict how many more jobs will need data scientists. We can get a handle on how many data scientists are being trained at places like Galvanize, at universities, et cetera. But right now, the demand there's a gap, and the demand for those kinds of jobs is currently increasing. The demand will not increase forever. Within a given population, a certain max percentage of those jobs will need data science training, and then we need doctors too and all these other things, although they're introducing data science training into medical programs now. So I think the answer is we're a ways away from that, but it's probably within our lifetime. We'll certainly solve it within all of our lifetimes, that we have the right amount of trained people for the job. It becomes commoditized And then the next great thing, quantum computing or whatever, time travel, whatever it is, that starts to be where all the job gaps are.
Well, if we as a society continue to grow dependency on AI, then what is the contingency plan when it fails or is offline?
When the AI fails?
So basically, I think if I'm reading this question right, is that if we increasingly grow dependent on AI or machine learning or technology, meaning we are relying on them to run our cars, we're relying on them to manage our home security perhaps, we're relying on them in the healthcare system, what is the contingency when this technology, this AI technology fails us at a critical moment or it goes offline, for example?
So I'll speak to it from the, the tech sector perspective. There are failures, but so much effort goes into resiliency and fault tolerance for critical systems that it's really rare, not never, but rare that we see failures in critical systems. And the more critical the system is, such as a financial services data center versus a video streaming data center, the more they over-engineer for resiliency in that environment. That was in one of the, I won't say the company, but one of the financial data services data centers that nobody even knows about, really, just north of Round Rock on the way to Georgetown. And they literally, for a demo, just flipped the switch to cut off a whole bunch of the servers to prove how confident they were in their resiliency for it. So I think in consumer services, we see failures and we think that everything is fragile because suddenly the Netflix video stops streaming or one of our audio streams freezes up for a second or something. And there are going to be failures in systems. But the more we depend on these systems, the more we will also engineer resiliency and fault tolerance into the most critical systems. Everything from a UPS, an uninterruptible power supply, to backup systems, computing systems that replace those. The data is replicated in multiple locations, et cetera. So it's not inconceivable, but there's great attention paid. And the more critical the system is for life, or it turns out for money, the more they engineer resiliency and fault tolerance into the system.
Awesome, thank you. And I know, we've had different board members who are involved with blockchain. So kind of pivoting a little bit on the question, which is, what is the relationship between AI and blockchain? I know blockchain is a really popular technology. So if you could speak to what is that relationship between the two?
So I can be explicit about our relationship to blockchain right now. We have a fantastic partner who's based in the Maryland area, some former NSA guys who have a blockchain-based ledger system for graph databases, graph storage. And really the merits of their tool, as opposed to a more traditional graph database like maybe Neo4j, or something in memory like a NetworkX, lots of different options. The reason we're particularly bullish on Craxel's solution is because of their ability to do kind of two things. One, embed and tokenize security in ways that allow for us to observe patterns within that graph without exposing sensitive information in ways you really can't do with other databases. The second, I'll have three actually. The second is their ability to remove these chains, these relationships within the graph through a proprietary token technique, which is really interesting without disrupting the chain. And then the one that I'm particularly interested in personally, although the applications of this are still fledgling, is a field of algorithms called homomorphic encryption, which allows for the application of different algorithmic routines on data that exists within a cryptographically sealed state without ever exposing the data. So imagine you write the number 4 on a piece of paper, put it in a vault, and then I apply an operator against that vault. With the door closed, it says multiply everything in here by 2. And without ever opening the vault door, that 4 becomes an 8. The next time you open the door, it's an 8. It's a rough analog to what this form of homomorphic algorithms are capable of. It's a relatively, I wouldn't say it's a young partnership because we've been working with them for a while, but it is still in its infancy as a technology. But we're very bullish about the ability to perform all sorts of complex operations and inferences against the data set without exposing risk of sharing sensitive information.
I have nothing to add to that because Charlie knows so much more about that topic than I do, other than the fact that I found it was amusing when you asked a tech and security question and Charlie said a friend in the Maryland area, and then he proceeded to explain who they used to work for, as if we don't all know who tech security in Maryland area is.
How are we doing on time? It looks like we're a little past 8 o'clock now.
So we ended the formal event at 7:30-ish, as we promised everybody. We can do questions as long as you're willing, and as long as Charlie is willing. I've got my bottle of Blanton's. I'm good as long as we want to go. I am super impressed that we have 42 questions still in the queue. We have 74 people still online. I'll stay and talk. And Jessica, you can start promoting people to ask live too, right?
I can. Actually, how about this? Let's move from the Q&A. Sorry if you put something in the Q&A.
But ask
it's easier for me to
if they ask it,
if they move it in the chat. Well, if they move it into chat, I can quickly click on their name and turn them into a panelist.
Okay. So ask questions.
So if you have a question right now that if you just put it in the Q&A, put it in chat, and you'll be able to ask it live. We have a few more questions. Ooh, there. I don't see any questions coming up. Let me see. There. I see something. Dara, you've been texting all evening, so I am finding you, and we're going to let you chat with people. Hold on, Miss Dara. We will find out if Dara's about to rejoin as a panelist. We'll find out if she's on video. Dara, there you are.
She is.
You can take yourself off mute, Dara, but you've been.
Oh, you guys are so
You're a grad
nice.
student at Texas State.
Yes, I am.
Ta-da.
Yeah, and I feel like I'm talking with buddies because I actually grew up near the DC area. So I'm a patriot. I went to George Mason, and now I'm at Texas State learning all about UX UI work. And
Awesome.
yeah, and we've had to, when we do projects, we do all of the research and then we build prototypes. And I really would like to learn more about AI and its implications into digital products, because I would like, I don't have a math background, so obviously I couldn't make the AI live. But if I understand the concepts surrounding it, then I can use that in my prototype. So what are some good books about how to apply AI to digital products? Whether they be mobile apps, enterprise software. It doesn't even have to be within a certain vertical, but because I'm interested in all types of industries. So I didn't know where to start my learning. Because if I took a grad level class at Texas State about machine learning or AI, I probably wouldn't be able to pass because I can't handle the math and the science. But if I can understand a concept, then I can apply it. And have some
totally okay. Yeah, we can have Jay and Charlie give their favorite books. Nabira actually works with Galvanize as the head evangelist. So I'm sure they can give some suggestions for books. Jay's an educator by heart, and then we can ask somebody else one of their questions too. So
books
top
are sometimes
2 or 3 books.
Yeah, so books
Charlie
are sometimes more digestible than academic papers. That's why I asked.
So I'm going to make a timely recommendation because a friend of mine
listen to my podcast.
who's in and listen to my, no. So a friend of mine tweeted about it the other day, and he's an AI expert, does the math and science, blah, blah, blah. But there's a book for AI sort of for everybody that he tweeted about and said he was looking forward to reading it. And I thought, well, I'll buy that book too. I'm really good at buying books and less good at reading them. But I started reading this one.
Oh, great.
Artificial Intelligence, A Guide for Thinking Humans. And it is I would actually encourage everybody listening to read it, no matter what your expertise level is, mathematically and neural networks, et cetera. It's a good way to get a lot of context and perspective on it. And then I would echo what Jessica said. Then I would take, some online classes and things like that. And Navira and Galvanize are a great place to learn about data science in general, including AI.
Okay, great.
Charlie?
Oh, Navira's about to head out. Thank you, Navira. Charlie's going to give us his recommendations. I'll take over. Thank you, Navira. You've been amazing.
Thanks, Navira.
First, bye.
Bye, Navira.
Yeah, design is actually something that I hold a lot of respect and space for, given my time at Frog Design, which was fantastic. Probably be the second best job I ever had. I loved it there. My 2 cents is that design is actually all about helping human beings recognize themselves in experiences, and objects, and each other. And an effective design really requires a deep understanding, not a topical understanding, of what that means to have a specific identity, and to acknowledge that some of the things that we do can be distilled quantitatively, but there's still a lot of behavior that we exhibit that's made manifest in ways that we don't fully understand. So for that, I would not point you towards a specific book, but rather the works of an individual named Nicholas Felton. He is a designer and technologist who took several years of measuring his own life. So every text message he ever issued, every conversation he ever had, every letter he ever wrote, he put through incredible rigor and processing to get to the point where he could measure his own life. His treatise is called The Quantitative Self, I think. And there are various volumes. I think he did it for 3 or 4 years. But what was fascinating about it, and he actually, if you're really interested, I can make an introduction. He's a friend of mine. What I found really interesting about his work is that he illuminates all of these different components of the human condition and things that he responded to that he didn't really realize ever. But instead of contextualizing it through the eyes of a psychologist, he really contextualizes it through his environment and his experiences and the way he interacts with other people. It's a really, really interesting work. So yeah, I would say that's a very tangible introduction to how to marry the capabilities of machine learning or any type of automated observation with what it means to be an effective designer.
Thank you, Jay. Thank you, Charlie. No, I would love to talk to Nicholas if he's up for it. So
Wonderful. See, I love this new section of the event. I didn't remember, Jay, if I missed when you said how long we're going to carry on, but I do notice the numbers changing. But since you know Mike Graham, and he was just asking a question, I just promoted him to panelist too.
That's okay.
Mikey.
Hello.
By the way,
Mikey
I
Graham.
haven't actually seen Mike Graham in decades, but through the pandemic, we reconnected for a book club that I promoted on Facebook that I was starting. And so it's been one of the silver linings of the pandemic.
So I'll repeat his question. So currently we use computers based on silicon using digital technology and binary bits. There's research on using quantum bits. Our brains are analog and use a wet biologic-based computer, which is much more efficient at turning energy into computing power. Is there any research in building a wet biologic-based computer rather than a silicon-based one to physically emulate the human brain as a way to better achieve intelligence consciousness? Take it away, Mike, if you want to add to it too. Have other questions you want to amend it. I just want to make sure everybody knew the first question that we were addressing. But take it away, Genties.
No, that was my question. Do we have more physically a biological based computer that's more similar to our brains in order to try and emulate the intelligence that apparently currently only exists in human brains?
Well, Mike, I tried to say it earlier in my part of the presentation. Charlie's probably got some deeper knowledge on this, but I think both of us said we don't fully understand human intelligence, So the definition of artificial intelligence is hard because we don't understand how to define intelligence. So we define artificial intelligence sort of as some artificial system that seems like it's doing things that would normally require human intelligence. So we kind of punt on the definition of the intelligence part, right? But for those who don't know, Mike, he's a medical doctor. So part of me wants to be snarky and punt it back to you and say, well, if we knew enough about biology, we'd probably have a cure for this pandemic right now, wouldn't we? So we don't understand intelligence and we don't understand neuroscience. And there's still some basic things we don't understand about biology, or we'd be able to fabricate a treatment and a vaccine for COVID the second we finished its sequencing. We have sequenced it. We don't understand enough about the proteomics to complete the treatment or vaccine design yet. So there are research efforts in biocomputing, but I will tell you that the efforts in quantum computing and neuromorphic silicon-based computing and others are far better funded and farther ahead because we think they're more, probably largely because we think they're more tractable, and whereas we have a long ways to go in both, we're making process in neuromorphic computing that's silicon-based. We are making progress in quantum computing. I have not, maybe Charlie's aware of some more recent research, but I have not seen a lot of biological computing based advances lately, but I'm not sure it's very well funded either. Charlie, do you know better?
Yeah, well, I don't know if I know better. I mean, this is a particular area that I'm very, very keen on. I do not think that the synthetic intelligence that we seek to create will be derived from digital. I think it's actually much more like the joke I've made before that nobody laughs at because it's not actually that funny is that Ex Machina is probably not nearly as close to our future as Little Shop of Horrors is. In that, you know, the idea of a Venus flytrap that learns over time and makes observations. I would not be surprised at all if our current work in stem cell research, in our early work now in advanced forms of EEGs, in fact, there's an individual who, you know, a company here in Austin that's doing really cool things, a company called Wavi, free plug there for a firm that we're probably going to be doing some research with. There are, I think that is absolutely the space that we need to start investing more and more time in. And the other thing that is particularly exciting about organically based synthetic intelligence is that it provides some really fundamental medical assistance to people who need it, frankly. So imagine being able to, instead of trying to to repair damage in the neurosystem, being able to create a synthetic link between your brain and then a synthetic nervous system, so that you could basically fix paraplegics, you know, the affliction of paraplegia or quadriplegia, or fix you know, folks who suffer from all sorts of types of nervous disorders. I think that's very promising, and I think you know, my dad always says, you know, the biggest technological change between when I was a kid and when, you know, your age now was telephones. He's like, we never expected cell phones to be this gigantic. He thought we'd all be flying in cars by this point. I truly think, I look at my 1-year-old daughter and I think that the biggest change between now and when she's my age will have come from our ability to hybridize synthetic neural operations with biological neural operations, which will be a major stepping stone towards that organic synthetic intelligence.
Do you really think that a biological based computer is one generation away, that your daughter will see it? Or do you think it's more like 100, 200 years away?
I think the synthetic intelligence is 200 years away. I think, though, that our ability to help many nervous system afflictions through that research could easily be a lifetime, another 32 years away. I think that's actually very possible, and we've seen some promise from that, to be honest. Yeah, probably hundreds of years if we're lucky before we get to an actual Venus flytrap that needs to be fed.
Feed me Seymour.
Okay, Seymour.
Well, thank you. Who else wants to? I'm moving them to. Let me see. I'm moving to see who's still in the room and who's still here. If you want to put a next question into the Zoom webinar chat, I think we probably have the energy for one or two more. The gentlemen seem to be enjoying this. Any other people who are still here? We still got 56 people. In some Zoom meetings would be thrilled to get this, and this is our 2 hours and 15 minutes in.
That's right, it's 2 hours in. This is a good hardcore group. I like it.
I'm very
my old
impressed.
advisor on chat, and he hasn't asked a question. Craig Wheeler, why have you not asked a question?
I'll see if Craig is still here.
I see him.
Craig.
He did some of the AI podcasts with me and Byron Reese before.
Well, let's bring him on up as a little to talk to Chatty Chat.
There he is.
Thank you so much. Yep. I'm really enjoying this role, by the way, of just like promoting people up, and then
I've got to unmute. It's been fascinating. Okay. I've been particularly interested in this discussion here of the organic things. I think you're all still too pessimistic. I think Jay's point about the exponential growth, I think there are arguments that we're in a super exponential process. I stumbled across somebody who was extrapolating the gross world product, and you end up predicting instability to decide that it goes to infinity in 2047. And I don't know. So I understand what Charlie's saying. It may be hundreds of years, but I think it could surprise us. It being whatever you want to talk about, be faster than that. So I'm sorry, that wasn't a question. It was just a comment. But I've really enjoyed the session tonight. It's been great.
Well, Craig, I'm actually, you know this because I've been on a podcast with you. As much as I love and respect Charlie, I'm the opposite end of the optimism spectrum from him. I would never bet against Charlie, though. In fact, I would never actually bet against him because the guy manages a hedge fund, for crying out loud. So you don't want to bet against that guy. Oh, and then he hasn't even mentioned his race car pursuits and stuff and whatnot. So, but I'm a big believer in the exponential advance of knowledge. And Craig, you and I have talked about before that people believe that the exponent is actually increasing in the rate of knowledge, total knowledge in the human species. So I believe the biological computing thing is absolutely within this century. I merely was answering Mike's question, or actually mostly Charlie answered, but my answer to that would have been, I think it's absolutely within our lifetimes. I agree with Charlie that I think silicon-based technology enhancements like Neuralink and things like that are going to yield a lot of the early promise for addressing specific ailments and conditions and issues. But I certainly think we have a lot to learn from 5 billion years of the planet's existence and a few billion years of life's evolution that we'll figure out some things in biocomputing on them. I believe in our lifetimes. Quantum computing is probably the next big step function, but I think biologically inspired computing is, and actually all this AI topic is biologically inspired in silicon. But I think organic biological computing is probably the next one after quantum.
Okay, so if you'll bear with me, I do have a question for Charlie. So about this Neuralink kind of idea, if we get to the point where we can all read one another's minds, do you see anything other than a dystopia in that?
Depends on what you're thinking.
God. Yeah. So there are a lot of so we have to be very intentional about semantic overload, right? So let me address both of these things first. So in series, I'll try not to address them in parallel because it gets confusing. So semantic overload. My contention is not that knowledge isn't aggressively growing at not even exponential, but geometric rates, right? That's actually not the contention. The contention is that while operations and aggregation of insights have grown at those rates, understanding has not grown at those rates. In fact, I would argue, well, of course I would say defensively if I'm arguing it, that our ability to have understanding has actually regressed in terms of our effort and focus. What I mean by that is we may be able to have an incredible wealth of knowledge that's able to correlate disparate domains in radically fascinating ways. Fish markets in Japan having implications on language evolution in Western Europe, which has implications on the way companies are foreclosing in Buenos Aires. I think that's totally tenable. We're going to see a bunch of commodities in the next 20 years, 30 years that nobody's going to be actually trading against because we've been able to unearth how those are deterministic systems, right? Totally think that's tenable. And that's all the derivative value from our ability to aggregate knowledge or relationships, let's say, at that kind of geometric level. The problem is that fundamentally, we have not been able to unearth the simple mechanics of how some types of pattern recognition systems operate within our brain can then be recognized in the pattern recognition systems of other components of our brain. One of my favorite examples of this was the accidental observation that we can trigger nervous receptors to recognize different types of sensory capabilities. So a man who's blind, has been blind his whole life, can't see out of his eyes never functioned. A neuroscientist a number of years ago invented a tongue depressor that had very, very small electrodes. And with time, they were able to train this tongue depressor with electrodes to replicate the impulses that he would have received with his retina, and actually created a very pixelated, very small image in this man's brain based off of triggers on tongue receptors. So you imagine you put on a set of glasses, they have a camera built in, the camera feeds to this tongue depressor, and the tongue depressor is shocking your tongue. And your taste buds are confusing input signal from taste receptors for input signals from a retinal array, right? That is wild. The fact that that works is super mind-boggling. And even the people who came up with this crazy concoction fully admit that of the 50 layers that they have to get deep into understanding the neural operations and synaptic operations, they're like 2 layers in. I can post this. There's a video about it on YouTube. It's really fascinating. So maybe we're all talking about the same thing, but I think Dr. Wheeler and Jay are talking about the ability for us to create interconnected networks of topologies for a comprehensive knowledge structure. I totally think that that's growing geometrically. Where we have limitations is what the mechanics are for understanding one topology to have patterns that are then exhibited by other topologies. And that's really what the focus of my life's research is all about, our team's life's research is all about. To answer your secondary question, which is what on earth happens when we can all observe each other's thoughts? That's actually a really great question that we can't actually really even address the hypothetical. I hate to be that guy, but we don't know what a memory is. We don't really understand even the mechanics of a simple knock-knock joke. So when I trigger a word, if I say purple elephants, I actually have very little confidence that you're thinking about purple elephants within a context that I'll be able to recognize. And that if those same triggerings occurred in my own brain, if I would even be able to recognize that you're thinking about a purple elephant. In fact, years ago, we had 2 main schools of thought in neuroscience. Now we have 4, and none of them really agree about what's actually fundamentally going on with the twisting of proteins to accomplish that exact thing. It's a really fascinating problem. So in terms of what is a thought versus what is a memory, versus what is creativity, until we get better definition on all those, I don't actually know if that's scary, right? I don't know if that's a bad thing, because for all I know, memories, except for the part where we have access to privacy, are not actually cognitive capabilities, but instead rather this protein-based deep storage that we illuminate different types of synaptic patterns through mechanisms that now we don't even understand at all. So I don't mean to dodge the question, but of course, if we were in the position where we could read everybody's thoughts all the time, that doesn't have a lot of positive trajectories. But I also think that until we understand the brain better, I don't know if that's actually something that could be at risk. It may be that there are 7 billion examples of how a cortex is formed. how synaptic relationships and neural relationships occur. And we may never get to the point where we're even able to reconcile them. There may be 7 billion different examples that operate completely differently, like a fingerprint.
Look, there's Craig there.
Sorry, that was way
Thank
too long.
you. No, I love that. I loved also, Jay was like really appreciating some of the things you were saying too. We don't even understand the mechanics of a knock-knock joke.
Yeah, the only thing I'll add to that is, as much as, you know, Charlie and I both agree that we're at the beginning of trying to understand intelligence and creativity and just scratching the surface. I will say the silicon technologies are much better for memory. So human memories are malleable and error prone and whatnot. So that's one of those, and they've done studies. They've shown human memory is getting worse because we depend on other devices for memory. And I'm fine with that. Memory is not a cognitive, it's a storage capability. And unfortunately, our brains are not really good at keeping the accuracy of those memories. We sometimes mix them up and do crazy things to them. Memory is fascinating too.
Wonderful. I'm scrolling for questions. Let's see, does anybody have other questions that haven't been addressed yet that you want to engage with, or just want to come and chat with our hosts about? There's already been a request, though, to have a night just of Charlie. By the way, Charlie and Nate, a Charlie versus Nate night.
But they also mentioned Kim, and I think they were mentioning Kim. Was that Kim Kardashian?
I'm not sure.
Charlie, can you arrange for Nate and Kim to be in a debate, but with not Kanye?
Oh yeah, hangs out with Kimmy.
Nate Silver. Probably not. I mean, it's a real adversary. It's a real adversarial relationship we have. I mean, we do not see eye to eye on the nature of stats.
Oh, F1 driver Kimmy. F1 driver Kimmy.
Oh crap! He mentioned Kim Kardashian, so I was hoping that's who Brian meant. But all right.
Yeah. So we have a great relationship in the racing world. We worked with a Formula One team, built some really great relationships, helping them optimize their CFD or fluid dynamics, their computational fluid dynamics work in the a little bit, and then also some strategic intel on competitors. Really fun project. It's a big area of love for us is the racing world. We're glad people are racing again.
I love that. That's fantastic.
I think my company's team competes against your team, doesn't it?
It does, actually. But we say that, but we're not as competitive as Dell's.
Daryl Knight asked for the optic nerve reference. I'm trying to tie up some loose ends.
Yep.
And there are
I saw that
right
now.
Okay, well, pulling it up for you, Daryl. I just saw Mike. I know. Well, Mike was just on, but do you guys think that computers can be funny? I'm waiting. Could a computer be funny? And he references, if I started a poem with, there once was a man from Nantucket and asked fifth graders to finish the poem and make it funny, they could. Could a computer do the same?
Oh gosh, I would say from our greeting card case study that probably. I mean, it's you know, it's not actually that far off. And that project actually kind of scared the heck out of us because we realized how tenable, you know, in the right amount of time, you know, text summarization, entity resolution, and different techniques in NLP can be really effective at creating a synthetic curator of content, right? It's actually quite frightening. But yeah, I think, you know, I think joke is a really, you know, jokes are one of my favorite things to talk about in cognitive theory, right? A joke is a manifestation of your ability to bridge a topology through a pattern recognition that you are both immersed in and can remove yourself a layer from and appreciate. It's a really weird way of articulating it, but here's an example. I'm a dad now, so I'm allowed to tell jokes like this, but did you hear about the cow who got a promotion? He was found to be outstanding in his, yeah, he was found to be outstanding in his field. Terrible. It's a terrible joke. But what's actually going on, the mechanics of what's going on when we tell a joke is a super interesting problem that we are not that close to solving. In fact, we haven't really made a ton of progress in that problem of trying to understand how a joke is understood. So we have to reconcile that with this kind of relatively esoteric and unexperimentally corroborated theory on what's going on mechanically. So the going theory is that we have models that have these matrixed overlaps that we use, and then we use synapses to instrument those overlaps. So you have a model of cows on a farm, and you have a model of your career development, and that joke resonates because you have a semantic confusion between which of those two topologies you're discussing, and you bring them together, right? I'm making a bad joke even worse by biologically breaking it down, right? But that's just a theory about how that could potentially work. And until the point we can get to the point where we can track an individual neurons firing and the web of connections that it permeates through a cortex, we're really going to have a hard time answering that, because there are lots of logical ways that we can construct for understanding how a joke works. But until we have some experimental corroboration of that, it's kind of a moot exercise, to be totally honest. Again, shameless plug for the guys at Wavi who are on that super exciting and fun journey. And they're based here, they're based in Colorado and here in Austin.
I think that one is, I agree with Charlie. My glib answer was going to be, if you've ever seen an AI generated poem, then that's comedy. But my serious answer would be, it's so hard for us to score it, what is funny and what funny means, versus Charlie's really terrible dad joke versus a good Dave Chappelle joke. We don't know how to really grade that. So if you don't know how to score it, you can't train the data set for it. So we don't even know how to put that into how we find something funny. I mean, you could say, oh, well, we find some humor crude, and some humor dad joke funny, and some humor very clever, but we don't even know how to score it. With the current AI techniques, if you don't have any way to really figure out how to train the data set and train the model, curate the data set and train the model, it's going to be really hard. You're going to have a dud comedian stand-up routine. Some things will be funny, some will be terrible. You won't know what the next one's going to be funny or not. So that is something that's very much in that part of human cognitive capability that we don't know fully how to describe our appreciation and description of yet.
Wow. Oh, there was one that just popped up. I was going to ask for the final question of the evening, if there's anybody who wants to come and chat with the host for those final few minutes that we're here. Phil, because you're the first person to post after I said that, we're going to bring you on. Oh, there's two of you, Phil. Oh, no. Oh, then for sure I'm doing it. I'm going to do both of you because I see two Phils. I don't know which one's real. Oh, sorry. One's Royce Phillips. That's not. Sorry, Royce Phillips. Phil, can you hear us? You're on mute.
Phil?
I'm going to unmute you. I feel like this is what
Phil just
radio
asked a question that I
host
tried to text an answer to, but I texted it to Jessica instead by accident. Phil asked a question about, wait, is humor more difficult to train the model than over other pattern recode? Is that Phil? Are you here?
Oh, he's on mute.
He's still on mute.
Right.
Phil, the answer to that is, you can train the model if you can describe the ground truth data. And if you can describe the ground truth data for humor, then you can train a model with enough data that you have declared funny or not funny. You have some chance, but there's a semantic meaning in it. There's a style of humor. There's all these variables in it that are difficult to train. So it's relatively straightforward to train a machine learning algorithm on, is that image representing the numeric character 6 or not? But a real good answer to this, a real descriptive answer to this might be, if you try to train an AI algorithm to recognize handwritten numerals, and all the handwritten numerals are in black and white, then your probability goes down when the number is written sideways and in colors. And so then you have to go retrain it at different orientations and colors and things. And then it realizes the generalities of what actually you meant by that number. It doesn't have the same cognitive capability as we do for what a 6 is. And you take that for granted, but remember that cat example I mentioned from the NVIDIA engineer who trained his AI on a whole bunch of cat images and was only right 2/3 of the time. And then he realized, oh, they were all cute cat images. It didn't really understand the concept of a cat. It understood features that appear in images labeled cat. And so he had to give it a lot more images that were also labeled cat, of cats in other positions and poses and looks and stuff. And then it never really understood what a 4-legged mammalian domesticated pet was. It understood what the visual features are that represented a cat in an image. And so again, the power of AI and the limitations of the machine learning approach are such that you'd have to be able to describe the nuances and score it against the nuances of humor. And there's already the problem of understanding the semantic meaning of language. And then you've got to explain on top of that the human appreciation for humor. And what Charlie finds funny, I might not find funny, and vice versa. And so humor turns out, as I love Charlie's description, humor is a really difficult one. Machine learning jokes, that's a problem. Machine learning music, easy. Machine learning jokes, hard.